Okay, so this video is going to be on the effects of dilations page on length, area, and angles. And it looks something like this. Now, I'm going to switch to my version that I can write on, and you'll notice I've already made one very important difference, okay? I added a set of XY, an XY axis, basically, okay? Now, the reason why we want to do that is because I want to actually get coordinates for these points. That's going to make my life a lot easier if I know the coordinates of these points, okay? So what I would recommend, draw your x-axis through the lines through line AC, okay? And then draw your y-axis through point B, just because that'll make our life a lot easier. And you're going to do that for all of these, okay? So in this problem, we're going to be making 3 dilations. We're going to do a dilation with scale factor 2, a dilation with scale factor 3, and a dilation with scale factor C. Okay? Now, I'm not going to worry so much about this center A, center B, and center C. That's something that honestly is not worth us talking about. Okay? Let's just make the center right here in the middle. You have my permission to do that. Okay? Make this as easy as possible. Okay, so we're going to look for the first one with a scale factor of 2. Now, they did give us 3 graphs on these. So what I would do is on these other 2 graphs, give yourself the space to work through these, okay? Now, I'm going to do the hardest one here. I'm going to do scale factor of 1/2. I'm going to do part C, okay? Now, I'm going to do mine on the first one. You guys should do your part C, or number 3, excuse me, on the last one, okay? So please make sure you're putting this in the correct spot. I could do the first one, but then I'm saving you guys to have to do the hardest one. So I'll do the hardest one with you guys, and then I'll leave the scale factor 2 and scale factor 3 for you guys to do. Okay. So remember that when you take an object and you scale it by any scale factor, okay, by any dilation factor, we're going to change the coordinates of these points, okay? Let me get rid of this origin point real quick. Okay, so right now, let's figure out what are the coordinates of A, B, and C. Okay, so point A. Point A is going to be -4, 0. Okay, and point B is going to be 0, 4. And point C is going to be 2, 0. Okay, so now, I want to dilate this by a factor of 1/2. So what that means is I need to take all of these numbers and multiply them by 1/2. Or in other words, figure out what half of these numbers is. So that's part of the reason why I set up the graph the way that I did, is because now I have lots of zeros. So that means those numbers aren't going to change. The only thing, because when I multiply something by 0, it's still 0. The only things they're going to change are these non-zero coordinates, okay? So the 4 in point B, the 2 in point C, and the -4 in point A, okay? So what we're going to do is we're going to multiply those numbers by 1/2. So for point B, I take the numbers 0 and 4, and I'm going to multiply them by 1/2. So 0 times 1/2, and 4 times 1/2. Okay? Well, remember that 0 times anything is just 0. Okay? And 4 times 1/2, well, half of 4 is 2. Okay? So that means that I can go to the point 0, 2, and I can plot my point. Okay? So this is going to be B prime. In fact, let me change colors real quick. Let's do, sure, lime green. Okay, so B prime is going to be right here at 0, 2. Okay, similarly, A, which was -4, 0 to begin with, right? Well, the 0 part is going to stay the same. But half of -4, well, half of -4 is -2. So that means I'm going to plot the point -2, 0. Okay, so that means this is going to be A prime. Okay, and finally, our last point, C, which is 2, 0. Take 2, split it in half. That's going to give me 1, and the 0 part won't change. So if I plot that point, that is going to be C prime. Okay, now I can tell that I've done this correctly because I ended up with the same basic triangle. It's just kind of a smaller version. It's just shrunk down a little bit. Okay, so I have dilated this triangle ABC, by a factor of 1/2, shrinking it to a smaller version of itself. Okay, so here's what we're going to do now, because in addition, for all of these, so you're going to draw the dilation just like I just did. So I did the part for A, for number 3, okay, but now I need to answer these 3 questions, okay? What factor does the base and height change? What factor does the area change? And how do the angles of the scaled triangle compare? Okay, so let's take these one at a time. Okay, so our first question here, what factor do the base and height of the triangle change? Okay, so the base is going to be this bottom part of the triangle. Okay, so the measurement of AC, I count 1, 2, 3, 4, 5, 6. Okay, so AC, the original base, is 6 units long. Okay, my new measurement, A prime to C prime, is 1, 2, 3. Okay, so A prime to C prime, the new base, is 3. Okay, so how would you describe what happened to the base? Well, it looks like the base got multiplied, is half the base. Okay, so the new base is half of the old base. Okay, the new base is half the old base. Okay, and similarly, if I look at the height, so the height in this case is going to be this measurement. Okay, and that one, the original one, was 1, 2, 3, 4 units. Okay, and that's from the height is 4 units. Okay, and the new height, I'll just call it height prime, that's only 2 units. Okay, so again, the new height is half of the old base. Okay, it fit exactly with my dilation factor. Okay, because you can also look at this as a measurement of the triangle. That height also gets dilated by a factor of 1/2. Okay, just like the base did. Okay, so that puts it, we've done number 1. Number 2, by what factor does the area of the triangle change? Okay, so remember that the area of a triangle, so I'm actually going to need these numbers, so I'm going to leave them there. The area of a triangle is 1/2, whatever the base is, times whatever the height is. Okay, so if I do the area of the original triangle, okay, so that's the original printed triangle, it's going to be 1/2 times the base, which we said was AC from before, so times 6, okay, and then times the original height, which we said was 4. Okay, well, if I simplify this, 6 times 4 is 24, so it's 1/2 of 24. Well, half of 24 is 12. Okay, so that means the area of the original triangle is 12 units. And remember, we're always going to, when we give an area, it's always units squared because it represents how many boxes fill up that triangle. Okay, so 12 units squared. So now we're going to repeat that process. The area of the new triangle. Still going to be 1/2 base times height, but this time the base is going to be 3 and the height is going to be 2. Okay, so 1/2 times 3 times 2, which is 6. Well, 1/2 of 6 is just 3. So that means the area of the new triangle is just 3. Okay, so now this is something that seems a little bit strange, right? You'd think that the area would be halved, but it's actually not. How do you get from 12 to 3? Okay, what are you actually dividing by? You're not dividing by 2. This time, you're dividing by 4. Okay, and the reason for that is because both of these measurements, both the height, the base, and the height were cut in half. So that means it's a half times a half, which is where this 4 comes from. Okay? Now, a little fair warning. All of these problems will kind of follow this same basic idea, where the base and the height part will fit exactly what your dilation factor is, but your area part is going to change a little bit. Okay? So be sure to calculate the area for each and then see how you get from one number to the next. Okay? All right. So, as I said, you guys are going to do number 1 and number 2. So you're going to take the exact same triangle, ABC, and you're going to scale it with a factor of 2. Okay? And on 2, you're going to scale it with a factor of 3. Okay? So, draw those triangles. Recreate the original triangle down on the graphs below, and then repeat the exact same process we did. Okay? We do have one last one to talk about here, and that is how do the angles of the scaled triangle compare. Now, this isn't asking you to get your protractor out, okay? It's just asking you to look at these angles, okay? So, when you look at this angle and this angle, what do you notice? Okay? Those two angles are the same, okay? They are congruent. Okay, and similarly, if I look at this angle and this angle, angle B, okay, those angles are the same. Okay, and similarly, C and C prime, those are the same. Okay, so it turns out that dilations, the one thing they don't change, they change the sides, they change the length of them, but the angles stay the same. Okay, so my answer for my third one here would be the angles don't change. And my computer is struggling a little bit. Sorry about that. Okay. The angles of the scaled triangle compared to the original, you would say they are the exact same. Okay. So remember, I did the hardest one here. All you guys have to do is go back and go through and do 1 and 2. And you're going to repeat this process, basically do exactly what I did for all 3 of these options. Okay. So we did the first one together. You guys just need to complete the other 2.